Hi everyone, let's start today's daily challenge, that is daily temperatures. So in this question, we are given an array of integer called temperature, which represents the daily temperatures, and we have to return an array answer such that answer of I is the number of days you have to wait after the ith day to get a warmer temperature. All right. So what does that mean? That basically means if we come to this temperature array that is given to us in the question, and for 74, let's say I want to find out. So this is first day, second day, third day, fourth day, and so on. Right. So let me tell you here. Right. So we have to form this array called answer of I. Right. So first of all, it will be the same size of the temperatures array, and for each and every day, that is, let's say these are first, second, third, fourth, fifth, sixth, seventh, and eighth days, right? So what I have to return for 73, I have to return the next day. I have to return the next day when the temperature becomes warmer than today, right? So how many days are in between them? So I can see after 73 I have to only wait for one day, right, for the temperature to become warmer, because the next day the temperature becomes 74, which is greater than today's temperature. So we can simply say 2 minus 1, I have to wait only one day, so I can say 1 will be returned here. For 74, if I see, again just the next day is warmer than 74, right? So we can say 3 minus 2, that is 1. Then for 75, if we see, for 75 it is not 71 that is warmer, 69 is also not warmer, 72 is also not warmer, but 76 is more than 75, right? So after 75, right, after this third day, we have to wait how many days? 1, 2, 3, 4. So the fourth day I am going to have a temperature which will be warmer than third day, so I can return 4 here. Let's see for 71. For 71, 69, it is less. 72 is greater than 71. That means after fourth day, I have to wait for 2 days for the temperature to become warmer than fourth day. Correct? Similarly, for 5, we see it is just the next day, so I can return 1. For 72, just the next day, I can return 1. For 76, now in the question it's mentioned whenever, if there is no future day for which this is possible, keep answer of I equal to 0 instead, right? So here I can see that 76, right? After 76, we don't have any day which is warmer than 76, right? So I can return 0 in this case. Similarly, for 73, there are just no more days after 73. So I can return 0 here as well, right? So this is basically the question is, and I hope you've understood what the question basically wants you to do, right? Again, one thing to notice here is we cannot return any day which is warmer than today, right? Let's say for the first day, I can see it's the second day which is warmer, it's third day which is warmer than the first day, and it's seventh day also which is warmer than the first day, right? But I cannot just return any of the values at these days, right? I have to only return the next day, the first one, that is the second day, right, where the temperature becomes warmer, because only up to the second day I have to wait, right, for the temperature to become warmer than today. Correct? So this is the catch here. We cannot just return any of the values. We have to return the next one, right, after this particular day where the temperature becomes more. All right, so I hope this is clear to you. Now let us discuss how can we solve this question. So the first approach we can already see is that if I, for each and every day, will iterate in this array again, right? We'll iterate for all the temperatures after the current day and try to find out the very first value which is warmer, right, or more than the current day temperature, right? So I can simply say, for I'll start from I is equal to 1, I less than n, and I plus plus, right? And okay, this is I, and here I'll have another loop, right? For ith day, I'm going to check inside of this loop by again iterating in temperatures array which day is warmer than this ith day, correct? So I'll start from I plus 1, correct, and I'll go up to j less than n, and I'll do j plus plus, right? And then I have to simply check what day, right, which jth day the temperature becomes more than ith day. So I can simply say temp of I less than temp of j. Wherever this condition becomes true, there we have to return j minus I, right? So this is basically how we can solve this question. Now if you see the time complexity for this, it's big O of n square, right? But can we do better than this? So definitely Now let us see how can we perform more efficient than this particular solution. So let me first clear up the board a bit. So now what can we do, right? So if I observe the question a bit, I can see that I have to return just the next element which is greater, right? So if somehow I start iterating like this, right, and try to store temperature value somewhere and try to get to an answer, like let's say I start from here, right, and I store 73 then 76 and so on, and whichever was the last element that I stored, I compare it with the current element, right? And let's say if this is not an answer, go to the next element and keep doing it and so on, let's say, right? Then I can find an answer, right? So it's kind of intuitively I can do that, right? So we can use stacked data structure, right? So from our rendition, we can understand that somehow it is to do with the next temperatures, right? So what if we traverse the array in reverse order? So if we traverse the array in reverse order and we somehow store these values somewhere and get the last value which is greater, right? And let's say this value is not greater, move on to the next value, right? Reject this, move on to the next value, and keep doing so on, right? So I can see that whatever structure I'm going to use, there I have to do what? I have to check the last element that I've put inside of this structure, right? So which is kind of LIFO order. So whenever I have LIFO, I can say I can use a stack. Correct. So that is the intuition in the question. That is the catch of the question, that we have to use a stack data structure to solve this question, right? Now how stack is going to help us decrease the time complexity, right? So let us see. First, let's see how are we going to use this stack, right? So I'm saying traverse the array in reverse order. Okay, so now I can see that I have an empty stack here, right? So this is my stack, there is nothing. And I come to the first element in reverse order, that is 73. So because after 73 there was nothing, you can simply put 0. So I can say that if there is nothing inside of the stack, what can I do? I cannot do anything, right? I cannot check for any condition. So that means I have to simply return 0 in that case. Okay, so that is done. For 73 I have written 0, but I have to put 73 inside of the stack because for the next element that I will be accessing in reverse order, 73 could be an answer. Okay, so we put 73 here. All right, then we move on to the next element, that is 76. So for 76, what we will check? We will check what is inside of the stack, right? So what was the last element we put inside of the stack? So I can see it's 73. So but 73 is not more than 76, right? So what we will do, we will say please remove this element and try to go to next element inside of the stack. So what I'll do, I'll remove this element from here, and I can see that I cannot access any more elements here, right? So now my stack is again empty, so I have no choices. So if I have no choices to check for, then I can simply return 0 here. Correct. All right, now let's move to the next element. Again, store 76 inside of the stack because 76 could be an answer for any previous element. All right, so 76 is inside of the stack, and then we move to 72. So we come to 72, and first what we will check the last element that is inserted inside of the stack. So that is nothing but the top element. So we'll check what is the top element of the stack. So I can see the top element is 76. All right, and 76 is greater than 72, so I can say 76 is an answer, right? And it is the very first element that I got, right? Again, with 76 I will have to store the indexes as well. Why? Because by doing 7 minus 6 only I will get the answer, because this is of just 76 is of no use to us, right? Although it is going to give us an answer that 76 is warmer than today, but we want to return how many days, right? 76 occurs after the current day warmer, right? So we have to basically, so we have to store the index as well. So we have 76, and with 76 we'll store what was the index of 76. So I can see it's 7, right? So we'll store 7 here, 76 comma 7. So now to get an answer, I can simply take the current index and subtract from the index that is at the top element of the stack. So I can see 7 minus 6. So 7 minus 6 is going to give me an answer 1. All right. So because I didn't have to perform any pop operation on this stack, right? Why? Because we already got the top element, which is warmer. So we will do nothing. We will insert 72 because for some cases 72 could be an answer, correct? So 72 we have put inside of the stack, and then we move to the next element. 72 comma 6 we have to put, right? So then we can move to the next element, that is 69. So 69, then for 69 again, the same thing we have to do. The last element that we insert inside the stack, that is 72. So I can see that 72 is the last element, and this is an answer for this, right? I have to wait up to this day. So I can simply return whatever is the top elements index minus the current elements index. So 6 minus 5. So I will get 1, correct? Then I will insert this also. Why? Because this can also be an answer for any previous day. So we'll insert 69 comma it's 5, right? 5 index. All right, so now we have 69 comma 5 inside of the stack. Move on to the next element, that is 71, right? So we are traveling this way, right? 71. So for 71 again we'll check the top element. So the top element, I can see the last element that is inserted inside of the stack is not more than 71. So we'll say it's of no use to us, so we'll remove this from here. All right, 69 comma 5 is removed from the stack. Okay, now we have 72 comma 6. So I can see that 72 comma 6 is more than 71, right? So I can return 6 minus 4. So we get 2 and insert 71 comma 4 inside of the stack. All right. Then we move forward. We come to 75. So for 75, I can see that it is 71 is not more, right? It's the last inserted element. So we have to remove the 71. Okay, so we have removed 71. Then I can see that the next element, that is 72, it is also not more than 75. So I have to remove this as well. So we'll remove this. And then check for the next element. So the next element is 76. Now I can see that 76 is more than 75. So that means this is an answer, right? So I can return 7 minus 3 in this case, which is 4. All right. Good. Now I have to insert this 75 here inside of the stack. So 75 comma 3 we have to insert. And then we will come to this element 74. For 74 I can see 75 is already an answer, so I can return 3 minus 2. Then I will insert 74 here as well. 74 comma 2. Okay, then for 73 I am going to check. For 73 I can see that the top element of the stack, the last inserted element, is greater, right? So I can simply return 2 minus 1 in this case. So 1 is the answer. So this is how we can use the stack data structure to solve this particular problem. So now I hope it's clear to you, right? Okay. So this way, what will happen is the time complexity will be big O of n, right? Now, another question that might be coming to your head is, why does this stack solution always works, right? The stack solution always works because you can see that, so you can say that we are trying to remove elements as well, right? They can also be answers, but still the stack solution is working. Why is it working, right? Because we are removing some elements and we are putting new elements, right? So we are only removing elements if they are less than the current element, right? So for 71, right, we removed 69 from the stack and we reached to 72, right, which was an answer which was already inside the stack. But if I have removed 69, it is no use to us. Why? Because 71 is greater than 69. So if there is any day here, right, for which 69 could be an answer, 71 would be an answer, because it would be just the next day, right? So as we saw in when we discussed what the problem is there, that we cannot return, we don't have to return just any day, we have to return just the next day where the temperature gets warmer, right? So let's say there was some let's say instead of 75 there was 68, right? So for 68, 69 could be an answer, but 71 is also greater than 68, so I have to wait only one day, right, for the temperature to get to become more than 68. So that is why the stack solution always works, because we are only discarding values when they are less than the current element. And if they are less than the current element, that means if 69 is an answer for that solution, then 71 is also an answer to that solution, right? And it is most appropriate because it is just after whatever will be the previous element to it, correct? So this is why this stack solution works. and we have also discussed how this solution is working, right? And the time complexity for this would be big O of n. So this is the time complexity, and the space complexity will be big O of n as well, as we are using a stack, right? So in case, in the worst case, what will happen is all the elements of the array will be inside of the stack, right? So then so that will only happen when we have an increasing kind of a sequence, right? Then we will be getting all these elements inside of the stack, so the space complexity becomes big O of n as well, right? Okay, so I hope now it is clear to you what we are basically doing. Now another thing. So the other thing is that instead of storing 74 comma 2, what we can do is simply store the index, right? Because only index is useful to us. Why? Because we have to simply return how many days we have to wait. What are we returning? We are simply returning 2 minus 1 or 3 minus 2, or we are only playing with the indexes, right? So from, if I know the index, then I can get the temperature as well, because I have the array and I have the index. So I can get from temp of that particular index, I can get that temperature, right? So storing 74 comma 2 is not very useful, right? So instead of that, we can simply store the index, right? So if we have the index, we also have the temperature, but here we don't need the temperature anyway, we only need the index, and we have to only play with the indexes, right? So I hope now it is clear to you. Now let us go ahead and code it out. Okay, so here first thing we have to do is, first I'll simply take the array length here. So it's temperatures dot size. Then we will declare the stack. Now the stack will store, I'll write here as well, stack stores in indices of the temperatures. I'm very sorry, I'm very weak with the spellings. All right, with the temperatures. Okay, now we have declared the stack. What we have to do is only a simple iteration, correct? So that iteration we have to do in reverse order, right? So we'll start from n minus 1, right? So int I is equal to n minus 1 and I greater than equal to 0. We have to go to the first index and we'll do minus minus I. All right, we have done this. Now what is the next thing that we have to do? So we have to basically find how many, like what element or the top element of the stack which is going to give us a warmer day, right? If let's say it's not the current top element, then we have to simply pop that element, right? And we have to keep popping elements until we find an element which is greater than the current element, right? So before we push anything inside of the stack, we have to check inside of the stack the top element, and if the top element is not more, then keep on moving forward, like keep on popping the elements from the stack, and then stop when we get an element which is the top element of the stack becomes greater than the current element, right? So we'll write a simple while loop here. So this while loop will run. First of all, the stack shouldn't be empty because we are popping values from the stack, and then we have to check if temperatures of current element, it should be less than, right, temperatures of the top index of the stack, right? Now sorry, so this is the condition where we have to stop. So we have to pop elements, right? So we have to pop elements if the current temperature that we have is greater than or equal to the top element's temperature, correct? So in that case, we have to pop from the stack, right? Now this loop will stop when this condition becomes false or this condition becomes false, correct? So the stack becomes empty. Otherwise, the stack has some elements and this condition becomes false. That is, we get a temperature, a top element's temperature, which is greater than the temperatures of I. Then this condition will be terminated, correct? Then what we have to do? We have to check, right? If the stack is empty, Okay, we have to also declare the answer array here as well, right? So we'll simply go and declare vector int answer, and the size is going to be the same as the temperatures array, plus we'll initialize all the values to 0. Okay, so it is not necessary to do, but if you want to do, you can, right? So if the stack is not empty, then what we have to store? Then we have to store the top element of the stack minus the current element, that is I. All right, so why is that? Because we want to get the difference between, so we want to get the number of days when we have to wait, right? So if the stack is not empty, that means we have found a day which is warmer than the current day, right? So in that case, answer of I will simply become what? It will become st dot top only. So the st dot top minus I, right? So the top element index minus the current elements index. Otherwise if the stack is empty, then you have to put ans I is equal to 0, right? So this condition you can do if you are not initializing your array, but if you are initializing your array, then you can skip this as well, because all the values are already 0, right? And you are only changing values where the stack is not empty. So automatically all the values where the stack is empty will be 0 only. All right, so this is basically what we have to do. And after this, so we have got an answer, right? If we have got an answer, this is what we have stored. If we have not got an answer, we have stored 0. And after this, what we have to do? We have to push the element, the current element inside of the stack. So as we know, the stack only contains the indexes, so I have to push the I index inside of the stack. So all right, so that is done. So basically with this iteration, we will get the answer array, and here we can simply return answer array. All right, so let's quickly run this. All right, so it's accepted. So basically this is how we have to solve this question. So I hope you have understood how to solve this question, what is the space and time complexity of the question, and why the stack solution works. So the main logic is how and why the stack solution is working in every case, right?